Greetings, respected FAT team. Our topic is dynamic vehicle routing and route optimization with cross-docking for efficient daily logistics operations. We are from Tyagaraja College of Engineering, Madurai, and our guide name is Dr. P. Chitra and our mentor is Dr. Arul Alan Rajan sir. We, the students, Ashok Kumar, Jili Bhaskar, Harish, and Tanush, have indulged ourselves in our project for FAD. The objectives of our program application is to develop a dynamic AI-based vehicle route planning for distribution of dairy products from suppliers to retailers with cross-docking, to reduce the transportation cost, carbon footprints, and travel time for transportation, to include practical constraints such as the demand of the product and heterogeneous vehicles to increase the practicality and applicability of the software in real-life scenarios. We'll see more about the demand of product and heterogeneous vehicles in the product demo. To develop a user-friendly application by incorporating the principles of UI/UX design to ensure seamless interaction between the user and the software. Let's see the product demo. Let us see about the first action that we're going to perform in our application. So first we'll go with the warehouse details. By selecting the warehouse option in the configuration, we'll be able to see the summary of the existing warehouse details which we have already entered. We'll be able to add new warehouse, update existing warehouse, and delete an existing warehouse by selecting on the Actions tab. Let us now add a new warehouse. Here we'll be able to see lots of options to be filled in, which essentially asks us about the user that's the super user, the industry that's gonna use it, the warehouse name, the types of products that's gonna be used, and the location of the warehouses. After adding every detail, we can we'll be able to create a new warehouse, and after creating it, that will be listed in the list of options of existing warehouse. So now we've created a new warehouse and a popover shows us that the warehouse is successfully created. So now we can see the new warehouse that's been created and displayed in this list of options. The next option is the transportation vehicle details. By clicking on the transportation vehicles tab, we'll be able to see all the list of different vehicles along with their vehicle type, their license number, the driver number, and the equipment capacity, that is the vehicle's capacity. So here also we'll be able to add a new vehicle, edit an existing vehicle, and delete a vehicle. Let us now add a new vehicle. Here the equipment number means the vehicle number, and there are different types of vehicles used in the industry. There can be lorries, there can be tempos. So we have generalized our application so that it can not only be used for dairy industry, it can be used for any industry that is using cold chain logistics. So our application can be generalized for cold chain logistic organizations and also other organizations that uses route optimization that is in need for route optimization. So after entering all the details, we can see that the new vehicle is created. So now we have added a new vehicle and we've also given provision such that a new user will not be able to accidentally delete or edit or use or the user must know a prior knowledge about our application to use it. So we have made sure that the user will not be able to delete it or update any entries without selecting on the vehicle first. So by this, we have made sure that no new user will be able to mistakenly delete a vehicle type or edit a vehicle type. So from the transportation vehicles, we'll be moving to the destination locations tab. So after clicking on the destination locations tab, we'll be able to list view a list of villages and their demand of the product and the address of each villages. Since there can be lots of villages in our route optimization, we have given the provision such that we'll be able to search for the village and easily retrieve the data of the village in the search bar. So here we have search for the address of the village in the search bar, or we can also search for the village directly in the search bar. By this, we can edit an existing village by searching for that village from in the search bar, and we'll be able to edit the details if there's any error in the details. Now we have changed the demand of the product for that particular village and click on Save Changes option. Now it has successfully been changed. Now, if we want to delete any village from our route, or remove the village, we can just select on the village ID or the whole village tab, and then we can click on the actions bar to delete that village. So after deleting that village, we'll no longer need to serve that village the product. So by this, we've included the functionality of adding new villages, removing the villages, or editing an existing village so that whenever the demand of that particular village changes, we'll be able to easily update the village demand in this tab. So here we have introduced the dynamic capability of our application such that we'll be able to use this algorithm and product for any capacity, for any demand of the village, and any type of village or any vehicles that is different, that is used in the industry. Now, after moving from destination location, we'll go to the transport logistics systems. This is a masterpiece of the product where the final outcome of the route is displayed. From the algorithm, we have calculated the route based on the traffic congestion, based on the vehicle fuel consumption, based on the greenhouse emission. And the main and the most important part is the time and distance taken for the vehicle to reach the destination. By taking all that into consideration, this route planner will display all the destination locations, the transportation type of vehicles, and the warehouse details, also the route in the map. In this map, we also shown an exclamation mark where we'll be able to see what type of uh, difficulty that faces. Here it is saying that it has scheduled construction where slow traffic is there due to road work. And we've also mentioned the start time and the estimated end time for that work to be completed so that the driver that is driving in that route is aware of this and they'll be able to take a detour of this. So now we have planned a future work here, that is the inclusion of GPS, that is to enable tracking of the vehicles so that whenever a vehicle is deviating from a given path due to some difficulties like this or due to some unexpected situations, we'll be able to keep track of that vehicle and we'll be able to update that driver with a different route so that we can optimize the path even when we are facing with sudden situations such as any road accidents or road blockages due to heavy rains or landslides. So here we are taking care of all the different um, situations that might occur, which can be of hindrance to our path road planning application. In this transportation planner, we'll be able to see list of destination locations, transportation vehicles, and warehouse details. Now we're going to select four villages according to our current demand. So the user will also be able to select whatever number of locations or villages that they want. And after selecting, if we click on submit button, we will not be able to proceed because we have not yet selected the transportation vehicle that is required. So now we are going to select transportation vehicles. And if we click on select, we'll still not be able to proceed because we have not chosen the warehouse option. So after this, we have to select a warehouse also from which the product will be shown. So after clicking on all the essential details that are required for our planning, if we click on submit button, we'll be able to see the route for our planning. So the algorithm is executed successfully and the results are being fetched. So now we'll be able to see the route that is required to be taken by the vehicle to cover all these locations in an efficient manner by taking into account the distance and the time, the fuel consumption, and the greenhouse emission of the different vehicles. So now we'll be able to see the different locations A, B, C, D, which is the four village, and also we'll be able to see the whole route for that D route. So there are two different routes that is displayed for this route planning algorithm. So there are two types of logins which will be used in this algorithm. One will be the driver login and the another will be the admin login. From the admin login, the role of the admin is to enter all the essential details that is required for the route and select the destinations, the vehicles, and the warehouses that is required. After selecting everything, the admin needs to submit the details so that our pathfinder will display the path. And then using the driver login, after the driver uses the login, the driver will be displayed the path that he or she needs to take in order to cover all the destinations in an efficient manner. So here we have used the driver login to log in into the application. So the login is successful. So the application is loading, and after loading, which the driver will be able to see the path that the driver needs to take. And there are multiple locations that is being displayed here, A, B, C, D, and two types of route that is displayed here. So using it, the driver can see the detailed path from A to B, from B to C, from C to D, and from D to E, and so on. So here we have provided the provision to see where the traffic is light, where the traffic is heavy, and the detailed route as much as possible. Turn left, right. So we've given everything that the driver needs to reach the location in a smooth manner. So this is all about the driver login. And the past, the addition of the details, the transportation vehicles, those were all the admin login. So now we have seen both the driver login and the admin login. So we have made it in such a way that the driver will not be able to uh, enter any details or need to think much or difficult for the driver to use the application. As long as the driver just remembers the username and password, the driver will be able to easily use our application and reach the destination on time in an efficient path and save the fuel cost, save the carbon emission, and contribute positively towards our environmental sustainability and greenhouse effect. Let us now talk about the results and discussions. We have calculated the route for 100 locations using different algorithms. The K-means algorithms is heuristic in nature, and the maximum entropy reinforcement learning algorithm, which we have designed. So by comparing both the results, we'll be able to see that the total distance is reduced from 1,242 kilometers to 893.6 kilometers, and the total travel time is reduced from 31 hours to 22 hours, which is a drastic reduction in time. And the transportation cost is also reduced from 49,704 to 35,744, and the carbon emission is reduced from 1,169 to 840 when we have used the maximum entropy reinforcement learning algorithm, which proves that our algorithm is performing better than the heuristic algorithm, which uh, denotes that our product is successful in displaying the route in an efficient manner and planning the route in an efficient manner.
Now we are at the end of our product demo. We are thankful for the entire FAL team for giving us this wonderful opportunity to work on this topic. We are also thankful for our guide and mentor for their support and guidance throughout our project. We hope that this product will be used by all the dairy logistic industry to find their efficient route and be benefited from our product. Thank you so much.